Welcome back to another walk and talk with Pilling the Cat. I'm the cat, gotta take my pill. As I said before, we take things day by day. So even though I'm 26 months sober, it means something, and at the same time it doesn't. It means that, yeah, I can achieve 26 months of sobriety in a straight run. However, we fall off the wagon sometimes. And what does that mean? Well, it means that it's a day-by-day thing. And that's the key point to this, that it is a day-by-day thing. So even if people fall off the wagon, it could still be a day-by-day thing after that. Just get back on the wagon again. Today is going to be about alcohol addiction and entropy. Wow. Yeah. What is that all about? Okay, so you're probably asking, well, what is alcohol addiction, right? No, you're asking what's entropy, maybe. Or maybe you know what entropy is, and you're asking what on earth does that have to do with alcohol addiction? Aha, okay. Well, let's get into a bit of what entropy is, first of all. So you're sitting at the bar with your pint of beer, and you drop your beer and it hits the ground, it smashes and spills everywhere. And the funny thing is that physics can explain exactly what has happened in terms of gravitational forces, fluid dynamics, the integrity of the glass structure. And once you're able to quantify how the beer glass fell off the table and went to ground and smashed on the ground and spilled everywhere, you can describe this mathematically. And that's very interesting because mathematics can also be reversed, which means that you can go from the start of the math equation to the end of the math equation, and you can even go in reverse and show that you can end up with the question from the result. And there's another type of reversal that goes on in physics, and it's a bit like, let's say, a clock mechanism, or at least part of it, that you can turn the mechanism one way and the clock goes forward, or you can turn the mechanism another way and the clock goes backwards. And in a way, it's like physics forward and physics backwards. Now, the interesting thing is that physics forward and physics backward, they're sort of co-equal in a way. There's no actual reason evident why the physics should run more forward than backwards. And it's a puzzle. And so this requires an explanation. Why doesn't a cracked glass on the floor with spilled fluids sort of reconstitute itself? You know, that the fluids go into the broken glass and the broken glass reassembles into a pint, and then it seems to defy gravity, float up into the air and sit on the table as if nothing's happened at all. Like, why doesn't it go in reverse? Because the physics seem to indicate that they're both equal happenings. And this is where entropy comes in. Well, thermodynamics is a number of laws, and the first one is like, energy cannot be created or destroyed, it can only change form. You've heard that before. And that's really one of the first laws of thermodynamics. And by laws, what science actually means is not that, you know, there's politicians standing around agreeing on what the law should be. It's a behavior of the universe. That's what a law is. The universe just behaves a certain way. And entropy extends from that behavior. And so there's a question such as, if you sit a cold object next to a hot object, why is it that the cold object will absorb some of the hot object? Like, why is it that they'll both try to achieve some state of equilibrium where they're both the same temperature? So scientists are noticing all things like this, and there has to be some explanation for these behaviors. And the scientist who is most popularized with explaining this is a scientist named Boltzmann. And he came up with something called Boltzmann statistical mechanics. Now, what does this mean? It's not as difficult as you think it would be, but it is when it gets down to describing it mathematically. But understanding it, it's not so difficult. So what Boltzmann is saying is this, that statistically, there's a higher probability of the glass falling from the table and smashing than there is a smashed glass reconstituting itself and landing back up on the table. And what's really important there is that he's not saying that one of those is impossible. He's saying that it's just improbable. It has a low probability. Aha! So what's going on there? Well, he's suggesting that this low probability event is something that does occur and can actually have explanatory power over why complexity exists in a universe which is tending to move towards less complexity. So what he's saying is that the arrow of time is really moving from complexity to less complexity. He's saying that it's more likely that in an explosion things will be blown apart than reassembled, but it's possible that there can be some reassembly of things, that some things come together. That's interesting as well, isn't it? So he's really talking about things in terms of probability. And this is where we get the term entropy from. It means things are going from order to disorder more than they are disorder to order. And this explanation of going from order to disorder really gives us this sense of a direction of time. So in a way, what he's saying is, if you had an infinite bar table with an infinite number of beer glasses on it, at some stage, one of those glasses would maybe reconstitute itself and go back up on the table again. Low probability events happen. They're just rare. And that's why we're seeing or experiencing the larger probability all the time. Now, the thing about entropy is that the universe is behaving this way as well. The model currently is that there was a Big Bang. So we have something that was complex going to less complexity in a way. That's a behavior of the universe. And cosmology would explain this better than I do. And you're probably asking at this stage, what's all this got to do with alcohol? Once we realize that there's this direction towards disorder, we can ask questions like, well, why is there order in our lives? Like the planet, it's spherical. Why does it appear to be ordered? Or we can ask questions about ourselves. We're complex. There appears to be some ordering there. I mean, there's things going on which appear to be ordered. So why do they exist? And again, the answer is low probability events. Now, it might seem that this ordering is high probability, but in a way, it isn't, is it? I mean, planet Earth, yeah, it seems that we're alone. We do see other planets, and so while it's low probability that you'll win the lottery, there's a high probability that somebody's going to win it. Or maybe there's a mediocre probability that somebody's going to win it. But it's not impossible that somebody's going to win it. It's just a low probability of pointing out the winner before the draw takes place, okay? So learning about probabilities is definitely interesting because it has explanatory power, why things should be the way they are at all. So let's go back to talking a little bit about alcoholism and why entropy matters. Well, in previous videos I talked about how many things can appear as if you're swimming against the tide and you tire yourself out and you can't go on anymore. So why should that tide even be there in the first place? And the answer has to do somewhat with the direction of time and entropy. The disorderness is moving one way and we're moving against the disorderness to become more ordered. We start our lives as a single cell and then we become multicellular organisms, and the cells are replicating and their numbers are growing, and this is growth at its most fundamental. Our cells are replacing ourselves all the time, and so from that single cell we are growing constantly into a multicellular organism, and it's of a higher complexity. So why is that happening? Why are cells being replaced? Why don't they just live forever? And there are several answers to that. Some of them are genetic and some of them are more environmental. But a good example is oxygen. Now, anybody who works with metals in metallurgy or chemistry understands what rust is. I'm going to turn around now. Rusting. And oxygen, it oxidizes. It can cause rust to form on metal. It's as if it's transforming it, it's eating into it. And in a way, oxygen is quite corrosive. And yet oxygen is very important for some living things. Well, actually it's important for all living things, but in a different way. Some living things don't use oxygen to respire. They're called anaerobic as opposed to aerobic. But anyway, so we're breathing in oxygen all the time. Oxygen is also carried around our bodies by blood and hemoglobin. So this oxygen, it's important for us to live, but at the same time, it has properties which are associated with being corrosive. They have a negative effect on some things, including living things. And you may have heard of foods called antioxidants, yeah? An antioxidant food, and that they're good for you. Well, they are. And this is something which we can demonstrate, is that antioxidants help neutralize the effect of oxidation, which is why they're good foods. So the body is constantly having to replace cells that are being destroyed, partially because of genetics, partially because of environmental factors, but one of the most important of those is oxygen. So the body, in a way, it's swimming up against the current of oxidation. It's constantly replacing its cells in order to live, to grow and to live. And life, in a way, can be described as that sort of battle. There is an intrinsic competition at the biochemical level going on constantly, which we cannot avoid, but we can lessen its impact. And one way we can do that is through healthy living and healthy eating in order to encourage our body to be at its optimal, so that when the cell division is going on and cell replacement, that it's optimized, that it isn't lacking anything. And that's life. The body has to replace cells, and if it can't replace cells, then cellular structures can fail. And if cellular structures can fail, then organs can fail. And if organs fail, well, that is in the direction of being unhealthy. And of course, ultimately, life can cease. So there we go. That's a bit of the story of how entropy is relevant to our lives and how we live. It's much more important than what I've discussed, but if you want to look into things more, read about entropy, read about thermodynamics, and read about biological entropy and things like this, and the philosophy of life in terms of biomechanics and entropy. And it's very interesting. And some scientists, even though they're associated with other forms of science, like for example Schrödinger, you've probably heard of Schrödinger's cat, Schrödinger and quantum physics. Well, Schrödinger talks a lot about this aspect of life and thermodynamics, and how the body is constantly, or life should I say, is constantly in competition with this universe, which seems to constantly want to go towards disorder. And of course we see that as well. Buildings fall apart, you know, clothes, they get old, they fall apart, and not just through wear and tear, but just their existence. Knowing that things are constantly running towards disorder, this should explain something about the struggle that is life. And by doing a lot of this, we can numb the effects mentally by just trying to take our mind off these things, trying to reduce the stress of it all. But it's not successful that much, because it brings on its own problems, of course, which is alcoholism. And so the thing about quitting drink is not that things get better in a way that all your problems vanish. It's that you now are able to tackle your problems with a clear head. When we quit, we may feel that we're on a downward spiral. And the downward spiral is somewhat real. It is life. And there's nothing you can really do about that downward spiral in terms of its overall existence. It's there. It's a property of the universe. We're in a body that is competing against all of this entropy, and that's called life. And I'm talking about life in the biological sense of what is a living thing. I'm not talking about it in the sense of how to live your life. In fact, I haven't even touched on that equation, except maybe on the health part of how to live your life. That's another topic and is highly customized to who you are as a person. But again, by quitting drink, you'll find out who that person is a lot quicker. That authentic version of yourself. So, yes, the spiral is real, But alcohol is not going to slow it down. In fact, it's going to do the opposite. It's going to speed it up because your mind is going from order to disorder. You're drunk. And then, of course, there's the after effects of being drunk. The sickness that comes with it. The hangovers. The withdrawal. Delirium tremens. How it's difficult to deal with things going on around you. Being drunk on a downward spiral is just like getting the helicopter rides in bed after you've drank half a bottle of whiskey and several beers. So if you're ever in bed drunk and you get the helicopter rides where the room is just spinning, just put one leg out of the bed and put it on the ground, and that'll stabilize everything. And that's how you slow down those helicopter rides. And what's happening there is that you're actually grounding yourself with one of your feet on the ground. You're trying to stabilize, balance the situation. Yeah, helicopter rides. So you're on a downward spiral, and you add the helicopter rides into that. What hope have you of trying to maintain some sense of control? It's impossible. It's like you're on a roller coaster. You're just going down and down and down, and you're drunk. One big nightmare of just screaming and pleading for it all to stop. Well, it doesn't stop, but you can slow it down. You can slow it well down, and you can slow it down enough that the moments become more stabilized in themselves. There are lots of things in life that you can do to form complexity out of things that are less complex. In fact, that's how the wealth of nations was born. A person uses their hands to dig up the ground. They find the ore. They smash the rock against other rocks, and they're able to extract the better parts of this ore. And then they take the better parts of this ore and they are able to tie them onto a piece of wood. And now they got a tool of more complexity, and they dig into the ground with that handmade axe, and they take out more ore. And then they are able to smelt some of that ore down into a metal. And now they've got a more powerful axe. And they dig into the ground with the axe. And they remove more ore. And they smelt the ore into a horseshoe. And the horseshoe goes on the horse. And so what you're seeing there is how wealth is created. It's the work done to something to make it useful to somebody else who's willing to trade for it. And it all started off by doing a little bit of work to get there. Interesting, huh? So the human body, while it's constantly fighting against the effects of entropy and thermodynamics, as a person, we're also able to create. In fact, we're able to reproduce and create versions of ourselves as well. But that's life doing life's thing. What I'm talking about here is more about what you can do with your human self in terms of being creative, to do things that run against the tide of things going from complexity to lesser complexity. This will of the universe to seemingly head towards some sort of destruction of all things complex. And by the way, complexity does occur in nature. If you take dirt and you put it into a glass of water and shake it around, the larger parts go to the bottom, and then the lighter parts are at the top. And what you get is a gradient, which is a type of complexity. Another example of complexity would be the shoreline of the sea on the beach, pushing rocks and pebbles, and creates a very similar gradient. So what's going on there? Well, it's gravitational forces. Aha. So gravitational forces in their own way can actually shift the probability of things that aren't so complex becoming more complex. And gravity is the explanation for the spheres that we see created, which we call planets. Is that small particles are being drawn together, and then they clump together and they accumulate over time into these spherical shapes. Again, the low probability event of complexity from something that isn't as complex. It's a low probability event, but not impossible. And the force of gravity is what nudges the probability a little more towards complexity. Thank you for today's walk and talk on alcohol addiction and entropy. And we'll talk more again another time.